Hello. Hello and welcome to this video. In this video, we will solve remaining problems of determinants. The link to download the PDFs will be in description. At the end, I will show you how you can download updated PDFs and maintain a copy of that. I will also show you my question answer website where you can come ask and answer questions. Come and ask and answer and what's missing. So we have question 172, which I said that I will expand on it. So the problem you remember from the previous video, so that sin x plus alpha, cos x plus alpha, a plus x sin alpha, and so on, we have BC here and beta gamma is independent of x. So you see this determinant, okay? Now from trigonometry formula, we know that sin x plus theta is equal to sin x cos theta plus cos x sin theta, and cos x plus theta is equal to cos x cos theta minus sin x sin theta. Now, if you perform C1 cos x minus C2 sin x, what will happen is it will become sin x cos theta cos square x sin theta sin x cos x cos theta sin square x sin theta. Now these two terms will cancel, first and third, and second and fourth we can take sin theta common and it will become cos square x plus sin square x sin theta. That is, the final value would be sin theta. So here theta means alpha beta gamma here. Okay? We are talking about alpha beta gamma. So what we do is we perform column 3 is equal to column 3 minus x cos x C1 plus x sin x C2. Once you do that, the third column will become ABC. And now what you can do is you can split the first two columns and we'll get 4 determinants. And then you will see that 2 determinants cancel each other and other 2 determinants become 1 by sin square x plus cos square x is equal to 1. So essentially it will reduce to sin alpha cos alpha A, sin beta cos beta B, and sin gamma cos gamma C. And there is no x here. So it becomes independent of x. So a bit of work we have to do. We split this. So for example, this will become sin x cos alpha plus cos x sin alpha, and so on for all this. Okay. So from sin x cos alpha, you can take sin x common. So this will have cos alpha, cos beta, cos gamma. And in the other determinant, in the split determinant, you will have cos x over here and sin alpha, sin beta, sin gamma here. So you can take cos x out. So essentially in 2 determinant, you have sin x out and cos alpha, cos beta, cos gamma, and then cos x out, sin alpha, sin beta, sin gamma. And here you can take cos alpha out. You will be left with cos alpha, cos beta, cos gamma, and then you take minus sin x common, and you will be left with sin alpha, sin beta, sin gamma. So then you can solve it. Okay. So we move on to question 173. It says that if f of x is equal to 2 cos square x sin 2x minus sin x sin 2x 2 sin square x cos x sin x minus cos x 0, so that integration of 0 to pi by 2 f of x plus f dash x dx is equal to pi. So we perform C1 is equal to C1 minus 2 sin x C3 and C2 is equal to C2 plus 2 cos x C3. So we have this determinant and it will eventually come out to be 2. So it's a constant and f dash x will be 0. So this becomes 2 dx and between limits 0 and pi by 2, and the answer is 5. Question 174 says that prove that a1 alpha 1 plus b1 beta 1, a1 alpha 2 plus b1 beta 2, a1 alpha 3 plus b1 beta 3, a2 alpha 1 plus b2 beta 1, a2 alpha 2 plus b2 beta 2, a2 alpha 3 plus b2 beta 3, a3 alpha 1 plus b3 beta 1, a3 alpha 2 plus b3 beta 2, a3 alpha 3 plus b3 beta 3 is equal to 0. So this is product of two determinants a1 b1 0, a2 b2 0, a3 b3 0, and alpha 1 beta 1 0, alpha 2 beta 2 0, alpha 3 beta 3 0. Now these two determinants are 0, so the product is also 0. Question 175 says that if LR I, vector I, MRJ and RK are is equal to 1 to 3, be three mutually perpendicular unit vectors show that L1, L2, L3, M1, M2, M3, N1, N2, M3 is equal to plus minus 1. So for we let this vector R is equal to LRI plus MRJ plus NRK. For R is equal to 1, V1 is equal to plus minus I. For R is equal to 2, V2 is equal to plus minus K and R3. For R is equal to 3, V3 is equal to plus minus K. So we get determinant as 1, 1, 1 in diagonal or minus 1 in diagonal and all other being 0. So the delta is plus minus 1. Need to know vectors to solve this. Question 176 says that let delta is equal to a1 b1 c1, a2 b2 c2, a3 b3 c3, and ai bi ci be the cofactors of ai bi ci small ones respectively, and alpha I, beta I, gamma I be the cofactors of capital AI, capital BI, capital CI respectively, where I is equal to 1 to 3, so that A1, B1, C1, A2, B2, C2, capital 1s, A3, BC, C3 times alpha 1, beta 1, gamma 1, alpha 2, beta 2, gamma 2, alpha 3, beta 3, gamma 3 is equal to delta to the power 6. So we have this matrix A1, B1, C1, A2, B2, C2, A3, B3, C3. And cofactor matrix will be capital version of that. Now adjoint of A would be C to the power T, but A of adjoint A is equal to mod of A times I. So this requires you to understand matrix. That is equal to product of A times product of adjoint I, that is mod of cube of determinant. That is adjacent of A is equal to A square. So determinant C is equal to A square is equal to A1 B1 C1 A2 B2 C2 A3 B3 C3. And similarly, we can proceed for the second level of cofactors whose determinant will be delta to the power 4, and therefore the product is delta to the power 6. Question 177 says that using determinant solve the equations x plus 2y plus 3z is equal to 6, 2x plus 4y plus z is equal to 17, 3x plus 2y plus 9z is equal to 2. So from Kramer rules, we have the determinant 1 to 3, 2, 4, 1, 3 to 9, that is the coefficients of x, y, z, and we evaluate it to be minus 20. Delta x, that is, we replace the coefficient of x with the constant terms on the right hand side. We get 17, 4, 1, 2, 2, 9, 1, 6, 3. Delta x will be minus 20. And similarly, we compute delta y and delta z respectively to be minus 80 and minus plus 20. Once we have that, x is equal to delta x upon delta is equal to 1, and similarly y is equal to 4 and z is equal to minus 1. Question 178 says that solve the system of equations ax plus by plus ca is equal to b, a square x plus b square y plus c square a is equal to b square, a cube b cube plus a cube x plus b cube y plus c cube a is equal to d cube. Will the solution always exist and be unique? So our delta is ABC, a square, b square, c square, a cube, b cube, c cube. That is ABC times a minus b times b minus c times c minus a. And similarly, delta x will be bbc, d minus b, b minus c, c minus d. And delta y will be acd, a minus d, d minus c, c minus d. And delta z will be abd, a minus b, b minus d, b minus a. And now we can find x, y, z. Now, if only two of ABC are 0, the given system of equations has no solution. If A is equal to B is equal to C and any of ABCD is 0, then the system of equations has infinite number of solutions. Question 179 says that determine the coefficients A, B, C of a quadratic function where f of x is equal to x square plus bx plus c, f of 1 is equal to 0, f of 2 is equal to minus 2 and f of 3 is equal to minus 6. So we have f of 1 is equal to 0, that is a plus b plus c is equal to 0. F of 2 is equal to minus 2, that is 4a plus 2b plus c is equal to minus 2. And f of 3 is equal to minus 6, that is 9a plus 3b plus c is equal to minus 6. Now we solve using Cramer's rule. We have delta is equal to minus 2, delta is equal to 2, delta b is equal to minus 2, delta c is equal to 0. So a is equal to minus 1, b is equal to 1, and c is equal to 0. Question 180 says that determine the quotient ABC of the quadratic function where f of x is equal to x square plus bx plus c. If f of 0 is equal to 6, f of 2 is equal to 11, f of 3 minus 3 is equal to 6. Also find f of 1. So f of 0 is equal to 6 means c is equal to 6. F of 2 is equal to 11 means that 4a plus 2b plus c is equal to 11. F of minus 3 is equal to 6 implies that 9a minus 3b plus 6 is plus c is equal to 6. So this is not 42, this is 4 and 2 is in the second column. And there seems to be a typing mistake. So delta is minus 30, delta is minus 15, delta b is minus 45. So we compute a is equal to half, b is equal to 3 by 2, and c is equal to 6. And f of 1 is equal to a plus b plus c, that is 8. Question 181 says that solve b plus c times y plus z minus x is equal to b minus c. C plus a times z plus x minus by is equal to c minus a. A plus b times x plus y minus cz is equal to a minus b, where a plus b plus c is not equal to 0. So our delta is minus a, b plus c, b plus c, c plus a minus b, c plus a plus b, minus c. So we perform R1 is equal to R1 plus R2 plus R3. The top row becomes a plus b plus c, which we take out. And then we perform column 1 is equal to column 1 minus column 3. So these are two zeros and our determinants evaluate to be a plus b plus c whole cube. Once we have that, we compute delta x, and delta x when we compute is equal to c minus b times a plus b plus c whole square, and x is equal to c minus b upon a plus b plus c. Now since the given system equations is cyclic, therefore y is equal to a minus c upon a plus b plus c, z is equal to b minus a upon a plus b plus c. Question 182 says that examine the consistency of the system of equations 7x minus 7y plus 5z is equal to 3, 3x plus y plus 5z is equal to 7, and 2x plus 3y plus 5z is equal to 5. So we compute delta, delta is 0, and delta x we compute minus 20. So by computing these two, we know that the system of equations is inconsistent and has no solution. Question 183 says that find the value of k for which the following system of equations is consistent. X plus y is equal to 3, 1 plus kx plus 2 plus ky is equal to 8, x minus 1 plus ky plus 2 plus k is equal to 0. So for system of equations to be consistent, delta is equal to 0. So we compute delta here, and it turns out to be 3k square plus 2k minus 5 is equal to 0. From this equation, we have got k is equal to 1 and minus 5 over 3. Last question of determinant says that find the value of k for which the following system of equations is consistent. K plus 1 whole cube times x plus k plus 2 whole cube y is equal to k plus 1 whole cube, k plus 1x plus k plus 2y is equal to k plus 3, and x plus y is equal to 1. So we write this in the determinant form and we solve, we get k is equal to minus 2. With this, we come to the end of 184 questions, or rather all questions in determinant. And then the next chapter is matrices. So let me show you the website. The website is astavatra.org. You can download algebra, trigonometry, and conometry PDF from second, third, and fourth links. And the downloaded PDF will not have dates, so you need to add this date with a PDF. Okay. I cannot put the date in the PDF because that will make all existing links invalid. Also, come after 15 or 30 days to see if the date has changed. And if the date has changed, you can download the PDF again. Once and the question answer website is page link, you can click it, or you come to kundika.astrology.org. I have created a tags, several tags for you: algebra, calculus, geometry, or non-geometry, probability, trigonometry. And if these tags do not fit your question, you can tag them under mathematics. So please make a login and ask questions or answer questions. I know that these days AI is quite powerful, and you can ask your questions, but if you want human interaction, you can come and join the community. So I hope that you have enjoyed this video and found it useful, and you got to learn something. So I'll see you tomorrow in the next video, and we will start a new chapter, matrices, and after that we will move on to miscellaneous questions. So thanks a lot for watching the video, and I'll see you tomorrow in the next video. Till then, stay curious, keep learning, and most importantly, enjoy.